Okay, so here are the answers for the lines of reflection worksheet. I did my best with trying to make them exact lines of reflection. So when you draw the line, you draw a line so that each point is equidistant from the line of reflection. So basically a reflection is a flip. And in reflection, it has the FL like a flip. So it's basically you flip that over that line. So just to check, make sure each point is exactly the same distance over that line. Now this is not perfect because my lines aren't exactly straight, but that's how you can check. Okay, this one you would draw here. So this point here on the circle would be equidistant of this point. Okay, this point and this point, this point, this point, and so on. Okay, so here would be the line of reflection there. Okay, then you had to draw these. So I did my best on this. Not great, but just so you know. And then you could draw this. It's not even really, it's just a quadrilateral. You could continue to draw that like here. Okay, this one would be down in here. Okay, there's the circle, there's the upside down or flipped over trapezoid, and there's the flipped over equilateral triangle. Now this one I didn't do, but just so if you flipped this image over here, this point would be at about here, and so on. Here you can create your own, have some fun. So if you have any questions on this page, just let me know. Okay, line of reflection, it's a flip. Okay, now math journal page. Oh no. Oh, there, okay. So this is the math journal page 275. So I'm not going to draw this because I can't do justice to it like you guys could have with if you have a template. So at this point, just flip it over, it'd be about here. And then you could do your equilateral triangle. And then your square would go there and so on. Okay, so you had to come up with these landmarks. So I already put these numbers in order from smallest to biggest. So now I can find the median. 1, 2, 3, 4, 5, 6. There's 10 numbers. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these two numbers are in the middle. And since they're the same, your median would be 6. Your mode, the most often seen number would be 12. There's 3 12s. Your maximum would be 12. It's the biggest number in your data. Your minimum would be 2 because it's the smallest. And your range is your maximum minus your minimum, which is 10. That doesn't ask you for your mean, but if you had to find the mean, you would add up all of your numbers and divide by 10. Just so you know. Okay, you had to order these from least to greatest. Well, when your denominator is the same, the smallest numerator would be your smallest fraction. So 1/7, then it would be 3/7. I'm not going to do this all just to save time. And then it would be 4/7, 5/7, and 8/7 would be your biggest. Okay, here, when you have the same numerator, your denominator tells you which one's the smallest. Now, since 12ths is the smallest size piece, 2 12ths would be your smallest fraction here. Then, and that's what makes this kind of tricky, is the smaller the piece, the bigger the denominator. So the next one would be 2/9. So it kind of goes backwards. Then it would be 2/5, 2/4, and 2/3 would be your biggest piece here. Okay. So C, we don't have the same numerator or denominator. So there's a couple different ways you can think about it. I would go like half. I know 1/2 would be half. And then compare to half. So which pieces would be smaller than half? Well, I know 2/7 would be smaller than half. Half of 7 would be 3.5. So that you could compare that with 1/2. Okay, so that one's out. That one's out. Now 4/9 I know is less than half because half of 9 would be 4.5. So I'd go 4/9 would be the next one because it's really close to half. So it's closer to half than 2/7 is. Whoops, that's not right. Okay. Now we have 3/5 and 9/10. Well, if you think about what's furthest away from half, would be 9/10, because half of 10 would be 5. But also I would think that 9/10 is almost one whole. If I had one more tenth, I'd have one whole pizza. So then that, and then 3/5. Oop, 3 is kind of hard to do on this. Okay, so I know 3/5 is a little bit more than 1/2, so I know that would go there. Another way to do this, and now that you guys are experts on this, is you could change all of these into a decimal. Like 1/2 is 0.5, 5 or 3/5 is 0.6, 9/10 is 0.9. Come on. 4/9 is, if you remember the ninth, is 0.4444444, or we can round it to 4/10. And the 2/7, not sure what that would be. It'd be about 0.2, almost, well, be a little more than 0.2. Oh, this is frozen here. So you could also turn all of those fractions into a decimal to compare those. Okay, number 4, all we have to do is insert the decimal point. So here I have one place behind my problem, so I need one digit behind in my answer. Here I have 2 digits, so I would need 2 digits in my answer. Here again I have 2, so I'd go here. And then here I have 2, so I'd go here. Multiplying is a little bit easier than dividing. You could also estimate, like this would be round to 10, so 8 times 10 would be 80, so 76 would be closest to 80, and so on. This is like half. 0.53 would be really close to half, so what's half of 14? 7, so on. So either way. Okay, number 5, Miki took 40 shots in a basketball game. She missed 30% of those shots. What fraction did she lose? Well, if you think about what's 10%, which is the same as 1/10, what's 1/10 of 40? Which would be 4. And I want 3 of those because 30% would be 3 of these. So 4 times 3 would be 12. So she missed, let's see, what fraction of the shots she missed? So I already figured that out. Sorry, kind of moved ahead. So she missed 30% or 3/10. Or you could also do 30 over 100. I don't know if that's my computer or what, but so she missed 3/10 or 30/100, which is 12 shots. Okay, perimeter. 18 plus 18 plus 3 plus 3. This would be 36 plus 6 would be 42 feet. The area would be 18 times 3, which would be 54 feet squared. 18 times 3, I think that's right, 54 square feet. So those are the answers. If you have any questions, let me know.